I'm going to put the worksheet on Classroom if you need it. A lot of this is review. I just want to give you guys an outline so you could just fill it in really quickly. The first thing is our Precomp definitions. So a function is going to be increasing on an interval. Oh, I didn't mean to say that word. Okay. It says f of a is less than or equal to f of b for all a less than b on the interval. That's what that notation means. And so we're just gonna fill in. Mary, do me a favor, just grab Naha's worksheet and fill in for her since she's listening but she can't read. Thank you. So right, if a is less than b, that's what it says at the end. So if I have one x less than my other x, if my first y is smaller than my second y, look up if you need to. That means that my function's increasing, right? For every pair of x's, if one x is smaller than the second x and one y is less than the other y, it'll be increasing. And then if the first y is bigger than the second y, it'll be decreasing. Does that make sense? Okay, so the first blank is increasing, the second blank is decreasing. The third and fourth one just remind you guys of your local max, local min definition. So we've got a local max at x equals a. If f of a is greater than or equal to f of x for all x near a. We have a local min at a. If f of a is less than or equal to f of x for all x near a. Forget the graph of y equals x squared on the worksheet for now. We're going to come back to it. We're going to come back to that other graph too. So just the calculus definition section. Are you guys in that midsection with me? A function f is what on an interval if f prime is greater than 0? F is what on an interval if f prime is greater than 0? Increasing. And then f is what on an interval if f prime is less than 0?
Decreasing.
Decreasing. Okay. We're going to come back to that graph. We know what it looks like when f prime is greater than 0. We know what it looks like when f prime is less than 0. What is true of f prime at local maxes and mins? What's true about f prime? It's 0 or doesn't exist. Good. What do we call those things? Critical points, right? Okay, and that's what your number 3 is. F has a critical point at x equals a. If f prime of a equals 0 or f prime of a does not exist. Right, you guys just fill in those little blanks. 0 or D and E. Alright. You guys are with me? All review of what we've talked about before. It's just that the last time we talked about it, we had no idea how to take a derivative, right? So now that we know how to take derivatives, we're going to talk about it again and be able to talk about, we did graphical interpretations and tabular interpretations and sign chart interpretations, and now we're going to do an analytical algebraic interpretation of finding all those things. There's a theorem there. It says that if f has a local max or min at x equals a, then x equals a is a critical point of f. So anytime we've got a max or min, we've got a critical point. Is the converse true? The converse would say if f has a critical point, then f has a max or min. Is that true or false? False, right? Why is it false? Give me a counterexample.
Discontinuity.
Not about continuity. If a function has a critical point, does it have to have a local max or local min?
No.
What are you graphing, Rohina? A cubic, right? Y equals x cubed. Y prime of 0 is 0, but there's no max or min there. So it's a critical point, but not an extrema. Give me another example. Critical point, but no extrema. How about 1 over x? Right? Y prime of 0 is undefined, which means it's a critical value. Okay, but there's no extrema there. Okay? Cube root would be the same thing. I have a vertical tangent there. Y prime of 0 doesn't exist. No extrema. Okay, so the converse is not true. Okay. Flip over to the back. First derivative test. Okay, first derivative test says if f has a critical point at x equals a, and number 1, I f prime goes from what to what? What am I interested in f prime changing? Positive to negative. Oop, positive to negative. Okay. What will f do if f goes from positive to negative? Increasing to decreasing. Okay. And if f goes from increasing to decreasing, then f has, right? Because the increasing to decreasing looks like that, so f has a local max. Okay. For step 2, it's just the opposite, right? If f prime goes from negative to positive, that means f is going to go from what to what? Decreasing to increasing. And that's going to be looking like that, and so f is going to have a local min. Okay. And then that for that last bit, for 3, if I said that if f prime doesn't change signs, I'll have to use some space in there. So if it goes from positive to positive or negative to negative, that's what I wanted in there, then f has neither a max nor a min at x equals a. Does that make sense? Right, that's the behavior on a cubic kind of thing. And we're going to talk about absolute extrema. And once we cover this on the worksheet, we're going to quit with the worksheet. And I'll show you guys how to functionally use this. Okay, do you guys remember what the definition was that f has an absolute max at x equals a if what is true? Think about the Precomp definitions of local maxes. And give me a definition of an absolute max. Say it again.
All points are lower than it?
Yeah, it's got to be the biggest value for all x in the domain of f. Okay, so if f of a is, all you have to fill in is the f of a is greater than or equal to f of x part. And I have the rest of it written out there for all x in the domain of f. Okay, and then f has an absolute min at x equals a if what? F of a is less than or equal to f of x for all x in the domain of f. Okay. Absolute maxes and mins, absolute extrema, can occur at where? Endpoints or critical points. Good. Okay, so at critical points or endpoints. Okay, so absolute extrema, absolute maxes and absolute mins occur at critical points and at endpoints. Okay. So then I wanted us to make a list of how to find absolute extrema. Okay. So absolute extrema occur at critical points and endpoints. What do you think my first step should be?
Find critical points and endpoints.
Okay, so let's start by taking a derivative. Find f prime. Good step 1, right? The second thing is going to be to identify the critical points. And again, that's where f prime is either equal to
0.
or f prime
D&E.
doesn't exist. Okay. Alright. What I should do once I have my critical points in my, well, I have my critical points, you should be given endpoints. What should I do? What's my goal if I want an absolute max or an absolute min? Tell me in like different terms. I don't necessarily want to change in sign because a local max could not be an absolute max. I want to find the absolute max and the absolute min. Okay, so that actually requires more work than what we have to do here. What are you saying? Look at the graph. Okay, I want to look at the graph without actually having to look at the graph. I want to consider the function. I wanna know about the function at my critical points or my endpoints?
You wanna take the limit or no,
Somebody mumbled it.
What value?
The y values. Okay, I wanna know what the y values are. Okay, so I wanna compare the y values at your critical points and your endpoints. We're gonna plug it into what though? Say louder, please. Into your original function. Okay. Okay. Step 4 is just gonna be to label properly. And the way that I want it labeled is how I wrote it right underneath there. The absolute max is this, it happens at x equals that. My absolute min is this, it happens at x equals that. In this spot goes my y values. Okay, the reason I want your answers to be given like this is because no matter what AP asks you, this format will answer it. Okay, so if they ask you for the absolute maximum value, this says so. If they ask you for where it occurs, this also says it. If they ask you for the coordinate of the absolute maximum, this is an acceptable form of a coordinate. Okay, but if you say, if I ask for an absolute maximum value, and you say it happens at x equals 2, you haven't actually answered the question. So you gotta be careful on that. Or if I ask you for the absolute maximum value, and you say, oh, it's the coordinate negative 216. That's not a maximum value, that's a coordinate. So this format of the answer will always answer the question asked, regardless of how they ask it, which is why I like to do that. Okay. I also gave you guys a worksheet. Okay, on that worksheet, your homework, you have two